the factor theorem notes from last Friday, as well as division worksheet number 2, gave you problems where if I give you a polynomial and I give you one or two of its roots, you can find the rest of the roots. So the final type of complex conjugate theorem problem is that type of problem, but now we're going to have complex roots. And so there's going to be two ways that you can go about doing exactly what you did on those last 6 questions of division worksheet 2, as well as the notes from last Friday. So what we've got here is we've got a quartic. You notice that this quartic has nothing but real numbers in it, and yet x equals 3i is given to us as one of the roots. Well, what the complex conjugate theorem says is that if there's no i's in the equation, then if x equals 3i is a root, then so is x equals negative 3i. Okay, so that's the first thing, is we've not just been given one root, we've actually been given 2 roots. So then the question becomes, how do we pull those 2 roots out? So some people really do not like working with imaginary numbers. So method 1 is going to be long division. So what we do is we use this concept. If I asked you, is 12 divisible by 2? Hopefully your answer would be yes. And then if I asked you if 12 is divisible by 3, then once again, hopefully your answer would be yes. Well, if 12 is divisible by 2 and it's divisible by 3, then that automatically means that 12 is also divisible by 6, which is the product of those two things. So what we know is that if x equals negative 3i is a solution, then x plus 3i is a factor of our polynomial, and it would divide out perfectly. And if x equals positive 3i is a solution, then x minus 3i is also a factor, and x minus 3i would also divide out perfectly. So if x plus 3i and x minus 3i will divide out of our polynomial perfectly, then so will their product. Just like if 2 divides out perfectly and 3 divides out perfectly, so will 6. So if you want to get rid of the imaginary numbers, you can figure out what the product of these two things is, and then you can divide them out. So what you would do is this. You would figure out if x plus 3i is going to divide out perfectly and x minus 3i is going to divide out perfectly, figure out what their product is, because their product will also divide out perfectly. So we FOIL, and these are conjugates of each other, so what we get is we get x squared minus 3ix plus 3ix minus 9i squared. And so the 3ix's cancel, and the minus 9i squared becomes a plus 9. So what we have is we have x squared plus 9. So I know I'm being very repetitive, but this is a difficult concept. So what we know is that if this will divide out of our polynomial and this will divide out of our polynomial, then so will this. So we're going to divide this new quadratic out of our polynomial. And that way we avoid working with any imaginary numbers from here on out. So I'm going to have to use long division because I'm dividing by a quadratic now. So I am dividing x squared plus 9 into x to the 4th minus 7x cubed plus 19x squared minus 63x plus 90. Okay, and so x squared into x to the 4th is x squared. X squared times x squared is x to the 4th. And x squared times 9 is 9x squared. So I line it up with the other x squared term, and then I subtract. Okay, the x to the 4th cancel. The negative 7x cubed carries down because there's nothing being subtracted from it. This minus needs to distribute to this positive 9x squared, so I end up with 10x squared. And then the minus 63x and the plus 90 carry down. So the next round, x squared into negative 7x cubed is negative 7x. Negative 7x times x squared is negative 7x cubed, and negative 7x times 9 is negative 63x. And when I take that row and I subtract it, both of them cancel out. And so all I have is the 10x squared that carries down and the plus 90 that carries down. Okay, last round, x squared into 10x squared is plus 10. And then 10 times x squared is 10x squared, and 10 times 9 is 90. And sure enough, when I subtract, I get a remainder of 0. Everything cancels. Okay, so just like on the factor theorem and just like on division worksheet 2, what we have just proven is that when you pull x squared plus 9 out of this quartic equation right here, that you are left with x squared minus 7x plus 10. Okay, now we already know the two solutions that are going to come from that quadratic because we're the ones who generated that quadratic, but we still need to find the solutions for this quadratic. And this one is factorable. It does factor as x minus 2 and x minus 5. So then we get x equals 2 or x equals 5. So I'm going to write those up here because it's asking for the remaining solutions. So negative 3i was one we had to figure out. It wasn't given to us. I mean, we knew it right away, but it wasn't given to us. And then x equals 5. So here's my remaining 3 solutions, okay, other than the one I was given. Okay, so I'm going to go ahead and I'm going to actually leave this stuff on the right because this should work out exactly the same way, whether I use method 1 or 2. So I'm actually going to go ahead and erase. So if you need time to copy this down, if I'm moving too fast, pause it for a second. I'm going to erase everything here on the left. Because then I can show you method 2. Okay, method 2 is to do this problem exactly like you did questions 13 through 16 on division worksheet number 2. Okay, you're going to pull one root out at a time. Okay, but of course our roots are going to be imaginary now, so they're going to be messier. So the first root I was given was 3i. I'm going to put that in the box for the synthetic division, because remember I'm now doing this just like those last 4 questions on the homework. And I'm going to divide it out of 1x to the 4th minus 7x cubed. And you want to leave yourself as much extra room as you can, both horizontally and vertically, and you'll see why. Okay, so minus 7x cubed plus 19x squared minus 63x plus 90. I'm going to leave myself some extra room vertically as well. Okay, and I carry the 1 down. So in my first multiplication step, not too big a deal. 1 times 3i is 3i. But now when I add down, those two terms, these two terms right here, they don't combine. One of them is imaginary, one of them is not. So I end up with 3i minus 7. So what that means is that when I do the next multiplying step, so now when I take 3i and I multiply times this, I have to distribute. So 3i times 3i is 9i squared. And 3i times minus 7 is minus 21i. That's why you needed all that extra room. Okay, and then don't forget, 9i squared is going to become minus 9. So now I add down. 19 and the minus 9 will combine and give me 10. And then I have that minus 21i. Okay, multiply again. So 3i times 10 is 30i. And then 3i times negative 21i is negative 63i squared, which is going to become a plus 63. So now when I add down, the 63's will cancel and I'll just have 30i. And then last time, 3i times 30i is 90i squared, which will become negative 90. And so when I add down, there's my remainder of 0. Okay, so remember those last 4 questions on the homework. Once we've pulled out our first root, we have reduced our quartic to a cubic. So this right here are the coefficients for a cubic, a very messy cubic. And so now I'm going to take negative 3i and I'm going to divide it out of that reduced cubic. So I'm dividing it out of here. I don't need as much room because remember that number 1, I'm going to get a remainder of 0. And number 2, I should end up in exactly the same place as I did right there. So all my imaginary numbers need to disappear right about now. Okay? So I carry the 1 down. Negative 3i times 1 is negative 3i. And when I add down, sure enough, the i's cancel and I just get negative 7. Multiply again, negative 3i times negative 7 is positive 21i. Add down, the i's cancel, and I'm just left with 10. And 10 times negative 3i is negative 30i, and so sure enough, there's my remainder of 0. And not just that, but there's this quadratic at the bottom, x squared minus 7x plus 10. So from that point on, the rest of the process is the same. So it's just a matter of, do you want to figure out what these two factors become and divide it out then? Or do you want to divide them out one at a time? At that point, the rest of the problem is the same. Okay? So what I'm going to have the kids in class do is I'm going to have them attempt this one for themselves. They're going to choose which method they prefer, and they're going to attempt it for themselves. So we do know that if x equals 2 minus I is a root, then so is x equals 2 plus I. And before I cut them loose, I'm going to remind them of yesterday's complex conjugate theorem video notes about when you write them as their factors, it would be x minus 2 minus I and x minus 2 plus I. So they need to make sure that those minuses distribute, if they're going to use method 1, of course. So it would be x minus 2 plus I for the first factor and x minus 2 minus I for the second factor. Okay? If they're going to use method 2, then they just use the 2 plus I and the 2 minus I as they see them. So go ahead and pause it, give it a shot, and I will, when you come back, then I'll have the answer for you. Okay, let's see how you did. Okay, so if you I lost my intermediate step. So if you did method 1, so you multiplied these together, you probably did some version of long multiplication to figure out what quadratic it becomes. So x minus 2 minus I. So if you did that, you would have had minus I squared, which would have become a plus 1. Then you would have had plus 2I, then minus ix. Then you would have had a minus 2I. Then you would have had a plus 4. And then you would have had a minus 2x. Didn't give myself enough room. And then you would have had a plus ix. And then you would have had another minus 2x. And then you would have had an x squared. So you would have had x squared minus 4x plus 5. Okay. So, then what you would have done is you would have done long multiplication or long division, and you would have had x squared minus 4x plus 5 divide into x to the 4th minus 6x cubed plus 12x squared minus 6x minus 5. X squared into x to the 4th is x squared. X squared times x squared is x to the 4th. X squared times minus 4x is minus 4x cubed. X squared times 5 is 5x squared. Take that whole row and subtract. So those would cancel. The minus 4x cubed would become plus, so you get minus 2x cubed when you combine them. Plus 7x squared minus 6x minus 5. Then x squared into negative 2x cubed is negative 2x. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 4x is positive 8x squared. And then negative 2x times 5 is negative 10x. Take that whole row and subtract. So those will cancel. The 8x squared will become a minus, so you end up with minus 1x squared. and the minus 10x will become a plus 10x, so you get plus 4x, and then you get the minus 5 that carries down, and then x squared into negative x squared is minus 1. And so minus 1 times x squared is negative x squared, negative 1 times negative 4x is positive 4x, and negative 1 times 5 is minus 5. And so when you subtract, you get your remainder of 0. Okay, and then what that means is that, let me erase this. Okay, what that means is that when you pull x squared minus 4x plus 5 out of your quartic equation, you are left with x squared minus 2x minus 1. Okay, and once again, we already know the two solutions that come from that quadratic. We need to find the two solutions that come from this quadratic. This quadratic is not factorable, so you would have to use the quadratic formula. It's not going to give you imaginary answers, but it will give you irrational answers. So when you take this one and you do the quadratic formula, what you should have gotten is x is equal to 1 plus or minus the square root of 2. Okay, and so that would be your final two solutions. So here are the three solutions we were missing from that quartic. Okay, synthetic division will do the same thing. It's just harder this way because when you divide the first root out with synthetic division, you're going to be foiling at a couple of those multiplication steps. And then, of course, when you divide the 2 plus I out in the second synthetic division problem, stuff will cancel. You're not going to be doing any foiling or anything then, but that first synthetic division round is pretty messy. So if you want to see it, you can go to the binder page and you can just look at the completed notes and see what your numbers should have been if you made any mistakes. Because remember that synthetic division, method 2, should put you in exactly the same place. You should have still ended up with this quadratic remaining after you did both rounds of synthetic division. So let me know if you guys have any questions. I'll see you in class.